Chapter 20 review, number 3. A group of 50,000 tax forms has an average gross income of $37,000 with an SD of 20,000. Furthermore, 20% of the forms have a gross income over 50,000. A group of 900 forms is chosen at random for audit. To estimate the chance that between 19 and 21% of the forms chosen for audit have gross incomes over 50,000, a box model is needed. A. Should the number of tickets in the box be 900 or 50,000? 50,000, that's the population. Each ticket in the box shows a 0 or a 1 or gross income. Are we adding up how much people make, or are we counting people? We are counting people. We want to know how many people are over 50,000. So a 0 or a 1, that's a counting box. True or false, the SD of the box is 20,000. False, the SD of the income box is 20,000, but the SD for the counting box is determined by the percentage using the SD shortcut. Okay, true or false, the number of draws is 900. True. And then find the chance that between 19% and 21% of the forms chosen for audit have gross incomes over 50,000. So we actually need to do this. Do I care how many tickets are in the box? No. So what am I going to put in the box? 20% ones and 80% zeros. So I've taken everybody's income and I've called them a 1 if they make more than 50,000, and I've called them a 0, they're under 50,000. And then it turns out I don't even care how many tickets are in the box. As long as I know the percentage, that's enough for me. So my expected value for percentage is going to be 20%. And I've just skipped a whole bunch of steps. I didn't add the tickets in the box together. I didn't take the average of the box. My expected value is the same as what is in the box. So essentially, I've gotten rid of the tickets. And I've just said 20% are yes and 80% are no. So now I need to calculate the standard error for percentage, which is going to be the square root of 0.2 times 0.8 divided by the square root of the number of draws, which is 900. So the square root of 0.2 times 0.8. And again, this is the SD of the box. And I divide that by the square root of 900. And that needs to be turned into a percentage of plus or minus 1.3%. Now what do I do? Chapter 5. My expected value is 20, and I want to know from 19 to 20. Should I use edges? How many draws did I make? 900. That's quite a few. So I'm not going to worry about edges. So that's plus 1 and minus 1. And 1 divided by 1.3. Oh, sorry, 21. Isn't it 21? Yeah, I wrote it down wrong. So I get a z-score of 0.77. And the nice thing is, it's a positive z and a negative z. So I don't need to shade norm. I can just look at my table. So I go to the table, 0.77, which is 0.56. So 56%. All right. Wait, is that everything? Yes. Oh no, F. With the information given, can you find the chance that between 9 and 11% of the forms chosen for the audit have gross incomes over 75,000? Why not? We would need a new box. And we can't predict how many are above 75,000 because we only know that 20,000 of them, well, you could probably do that with the SD. So we know that the original was 73,000, or sorry, 37,000, and then we knew that at 50,000 there were 20%, because we do know that the SD is $20,000. So it is possible to come over here to 70,000 and find a z-score that would spit out a percentage. And then we could use that percentage and create a new box. The only problem is this isn't very normal, right? If the average is 37 and the SD is 20, then the graph probably looks something like this. So the answer technically is yes, but it's probably not going to be very accurate because this curve is not normal. So who knows what they want, but we'll go with that answer. 4. As in exercise 3, except it is desired to find the chance that the total gross income of the audit is over the total gross income of the audited forms. Okay. So going back here, it wants to know the sum of 900 draws is 33 million or more. So basically, times everything we did by 900, right? So, well, no, not 900. The sum of the audited forms. Okay. That box is a counting box. We can't use it. So 37,000 is the average, and the SD is 20,000. So my expected value is going to be 37,000 times 900. Let's try that again. Oh. Okay. Darn it. That was so close. What if that number was a 0? What would the answer be? 50%. So my expected value is 333,000, and I want to know what is the chance that we end up with more than 330,000. I missed a set of zeros in there somewhere. Oops, that's one too many. So that is a gap of $300,000. And I need to divide that by the SE. The SE is going to be 20,000 times the square root of 900. So 20,000 times 30 is 600,000. So divide by 600,000, and I get, this is a negative, so I get negative 0.5. What do I do from there? Shade norm from negative 0.5 to infinity, yeah. So negative 0.5 to 5. Oh, there's my little tiny graph. And I get 69.1%. Okay. Number 6. Uh, the Census Bureau is planning to take a sample amounting to 0.1% of the population in each state in order to estimate the percentage of the population in the state earning or population in the state earning over 100,000. Other things being equal, the accuracy to be expected in California is about the same as the accuracy expected to in Nevada. True or false? Yeah. Oh, well, it wanted us to do all the A through E, but we just skipped to the end, and then it is possible. Yeah, because that's the important number. We did all the steps, we just didn't explicitly say it. Okay, so number 6. If we sample 0.1%, will the California numbers be more accurate than the Nevada numbers? Yes. Why? Because 0.1% of California is much larger than 0.1% of Nevada. As long as your sample sizes are the same, it doesn't matter. But we're not sampling a certain number, we're sampling a percentage. So in California, when you sample 1 out of 1,000, you end up with a lot more people than if you go to Nevada and sample 1 out of 1,000. So 2, the accuracy to be expected in California is quite a bit higher than Nevada. Yes, because 1,000th of California is much bigger than 1,000th of Nevada. So the answer is 2. 3 is false. And 7. 500 draws are made at random from the box, 60,000 zeros and 20,000 ones. The expected value for the percentage of ones among the draws is exactly 25%. Is our expected value exactly 25%? No, it's going to be 25%, give or take a certain percentage. The expected value for the percentage of ones among the draws is around 25%, give or take 2% or so. We're just going to assume that they did the SE correctly. Call that true. C. The percentage of ones among the draws will be around 25%, give or take 2% or so. True. The percentage of ones among the draws will be exactly 25%. False. The percentage of ones in the box is exactly 25%. That is true. The box is exactly 25%. The percentage of ones in the box is around 25%, give or take 2% or so. That's false. It's exactly 25%. All right, we're done.